Hey everyone! Welcome, St. Paul American School, Clark, Grade 9 students. I am so absolutely thrilled to be guiding you through today's explainer on coordinate geometry. We're taking a massive leap today, you guys. We're moving way past just looking at shapes, and we're learning how to unlock their secrets using the incredible power of algebra. So grab your notebooks, get focused, and let's jump right into the world of distance, midpoint, and coordinate reasoning.
Here is our roadmap for today. We'll cover 1. Lesson objective, 2. The midpoint formula, 3. The distance formula, 4. Worked example, 5. Misconception check, and 6. Formative check and recap. Let's get into it. Section 1. Lesson objective, unlocking coordinate reasoning.
So what are we actually doing today? Our exact goal is to learn how to calculate precise distances, find exact midpoints, and use algebra to actually prove geometric relationships. Let's look at this definition. Coordinate reasoning is basically using algebraic formulas to analyze figures and prove things on a coordinate plane, entirely without measuring tools. Think about why that's a massive deal. We're shifting away from just drawing a shape and holding a physical ruler up to it. Instead, we're using powerful algebraic formulas to mathematically and systematically prove things about those figures. It gives us absolute 100% certainty.
Section 2. The midpoint formula, finding the middle.
Now, before we start throwing any numbers or variables at a problem, let's just think about what a midpoint actually is conceptually. The midpoint is, quite simply, the exact point that divides a line segment into two equal pieces. If you have point A over here and point B over there, the midpoint sits perfectly halfway between them.
And here is the coolest part. The algebra for this is delightfully simple. To find that exact middle on a coordinate grid, you literally just find the average. That's it. You take your two x coordinates, add them together, and divide by 2. Then you do the exact same thing for your y coordinates. Add them together and cut them in half. Boom! The result is a brand new coordinate pair that represents your exact middle. It is wonderfully straightforward, right?
Section 3. The distance formula, connecting to triangles.
Okay, take a look at this. This right triangle plotted right here on the grid brilliantly illustrates exactly where the distance formula comes from. See those horizontal and vertical legs? Well, finding the distance of that diagonal line, the hypotenuse, is directly tied to a rule I bet you already know, the Pythagorean theorem. Remember a squared plus b squared equals c squared? It's a classic for a reason. That horizontal leg is your a, the vertical leg is your b, and that diagonal distance you're looking for, that's your c.
And that visualization tees us up perfectly for the actual distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, I know it might look a little intimidating at first glance, but honestly, it's just a direct, brilliant algebraic extension of that Pythagorean theorem we just talked about. The x2 minus x1 part, that's just finding the length of your horizontal leg. And the y2 minus y1, that's your vertical leg. You square them, add them, and take the square root to find that hypotenuse. Simple as that. Now, here is something absolutely crucial. You have to understand the structural differences between these two formulas, because this is where a lot of people trip up. Look at them side by side. The midpoint formula uses addition. We're summing the coordinates to find an average. But the distance formula, that fundamentally relies on subtraction. We have to subtract coordinates to find the physical difference or length of those triangle legs. Keeping that addition versus subtraction distinction locked in your brain is literally half the battle.
Section 4. Worked example, step-by-step distance calculation.
All right, let's actually run the numbers together. It's actually really satisfying once you get the hang of it. Step 1. We identify our points. Let's say we have point X at 510 and point Y at 24. Step 2. We plug those straight into our formula. Looking inside our parentheses, we subtract our X's. 5 minus 2 gives us 3. We subtract our Y's. 10 minus 4 gives us 6. Step 3. We apply our squares. 3 squared is 9, and 6 squared is 36. Add those together, and we've got 45 sitting under that square root. Now, the square root of 45 isn't a perfect whole number, but we can simplify it algebraically down to 3 root 5 units. See? When you take it step by step, it really doesn't have to feel overwhelming at all.
Section 5. Misconception check, avoiding common pitfalls.
So let's think about this for a second. What actually happens if you accidentally subtract your coordinates when you're trying to find a midpoint? Well, you'd end up finding half the distance, rather than the coordinate of the actual middle.
Remember, you have to add to find the average. On the flip side, what if you do all that beautiful algebra for the distance formula, but you just forget to apply that final square root at the very end? You're going to be left with the distance squared, which is going to be a massively oversized, totally incorrect answer. So always double-check your operations and never forget that final square root.
Section 6. Formative check and recap.
Okay, let's try a quick real-world scenario. Imagine a map superimposed right onto a coordinate grid. Your school is at one coordinate pair, and let's say a recycling center is at another. If you need to find the exact length of the straight path between them, which algebraic tool do you pull out of your toolkit? The midpoint formula or the distance formula? Think about it. Since we are looking for a physical length, the correct tool is for sure the distance formula. That right there is coordinate reasoning applied to the real world.
All right, to really lock this all into memory, let's run through a heavily structured recap of our core concepts. Number 1. The midpoint formula is all about finding the averages of your x and y coordinates, and you do that using addition. Number 2. The distance formula allows us to find exact lengths, and it's derived directly from the Pythagorean theorem using subtraction. And number 3. Coordinate reasoning. That's our ultimate goal here, using these algebraic formulas to prove geometry on a grid, without ever needing to pick up a ruler.
As we wrap up, I want to leave you with something to think about. If basic algebra can perfectly and undeniably prove the distance and the midpoint between two simple static points, how might this exact same coordinate reasoning let us analyze much more complex shapes? Like imagine proving a four-sided figure is perfectly a square just by looking at its coordinates on a grid. The possibilities are honestly endless, and you now have the foundational tools to start exploring them. Thank you so much for joining me for this Explainer Grade 9. Keep practicing, stay curious, and I'll catch you next time.